Okay, good morning. Doing this video over the 2E notes here. Should be pretty simple. This is just transformations on a coordinate plane. A lot of the concepts should be reviewed, from Algebra 1, probably even before that. So we're going to talk about translations and reflections today and maybe some dilations and rotations as well. Okay, so some of the simple uh, transformations. Okay, so let's say we have a triangle TUV with points TU and V right there. Okay. How do we translate it? Well, all we're doing is moving a thing. Okay. So we're moving a thing. And so all we're doing is we're going to move our three coordinates. Okay. We're going to, so our three vertices of the triangle are TU and V. So we're going to move those vertices accordingly. Okay. Well, if we translate it 4 units to the right, okay, what we're going to do is 4 units to the right means we're changing the X values and we're going to make the X values for, 4 units larger. Okay. So we're just going to add 4 to the X values. And now if we want to go 8 units down, okay, down, well, now we're dealing with the Y values and we're subtracting. So we're going to subtract 8 to the Y values. Okay. Very simple. That's it. Okay. So if we were going to do, TUV and we're going to translate it, to make it like T prime, U prime, V prime. Okay. So, T prime would be at 10, -7. U prime would be at, let's see, we add 4. So 2, -8. V prime, okay, we add 4. So it'd be 14, -16. Okay. We just add or subtract from the x's and the y's there. Okay, however much we're going, and that's it. Okay, so if we're going to translate a unit shape 5 units to the left and 2 units up, what we're going to do is we're going to minus 5 to the x values. Because if we're going to the left, the x values are decreasing, so we'll minus 5 from that. We're going 2 units up. What we're going to do is we're going to add 2 to the y values. Okay, really simple. So translation just means we're moving a shape, up, down, left, right, or whatever. So, however much left or right we're going to do, we're either going to add or subtract from the x's, and however much up and down we're going to do, we're going to add or subtract from the y's. Okay, simple as that. Okay, so that's the translation thing right there. Should be fairly simple. Okay, let me go to clear the screen here. All right, next, reflections. Reflections. This is kind of confusing here, so let's just make sure we pay attention. So if we have a 0.52 and we want to reflect it across the x-axis, so here's our 0.52. Now, if we're reflecting it across the x-axis, remember the x-axis is here. So we're going to take that 0.52, okay, and we're going to reflect it. So we go down by 2 to the x-axis. We're going to go down by 2 again to get our reflection point. Now, when we reflect across the x-axis, notice that it's the y value that changes, because if we're reflecting across the x-axis, we're going up and down. Okay, so the x value doesn't change. Okay, the x value doesn't change when we reflect across the x-axis. The y value changes; it becomes negative. Okay, so 5.2 becomes 5, -2. Okay, so all we do is just change the y value. Okay, now let's look at, we have a point -7, -3. So -7, -3, so it's down here. We're going to reflect this across the y-axis. Well, this is a y-axis right here. We're reflected across the y-axis, so we're going left to right. So we go over by 7 here to the y-axis. We go over by 7 again here, right? So -7, -3 becomes +7, -3. So what happens is, long story short, when we reflect across the x-axis, the y value changes signs. When we reflect across the y-axis, the x value changes signs. And that's it. Okay? The x value changes signs. Okay? So So that's that for reflections. Okay. Next we have rotations. Okay. Now rotations. Now we're rotating about the origin. Okay. So we're going to be rotating this about the origin. So we're going to talk about that now. All right. So let's say we have a 0.78. Okay. We have a 0.78, and we want to rotate it 90 degrees across the origin. Okay. So here's our 0.78. Okay, to rotate it 90 degrees across the origin, what we're going to do is we're going to flip the x and the y and change the value of the x. Flip the x and y and change the value of the x. Now, whenever we rotate, I should also mention that it's counterclockwise. Okay, so since we rotate counterclockwise, the rotation 90 degrees is going to put us in this quadrant. Okay, quadrant number 2. Okay, we're in quadrant 1, now we're in quadrant number 2. So we have 0.78. What we're going to do when we rotate it 90 degrees here is we're going to end up flipping the x and the y. And now the new x value, I should say, changes signs. So we go from 7.8 here. When we rotate it, it goes to -8, 7. Okay. Now, if we were to rotate this again, okay, so let's say we rotate 180 degrees. Well, we could take this and rotate that 90 degrees, or we could do this 180. But what would happen is this. Let's say we take this and we're rotating it down here now. Okay, so another 90-degree rotation from here to here. Right? Well, okay, if we rotate this 90 degrees, okay, now we flip these things and change the sign of the new x. So we flip these things back. So we're going to have 7, -8. And now the 7 changes to negative. Okay? And so, what this is, ladies and gentlemen, is now this is a 180-degree rotation from here, right? So 7.8, we rotate 90 to get here, and we rotate another 90 to get here. So from here, from 7.8 all the way to this pink point down here is a 180-degree rotation. And you see what happens is we end up just changing the signs of our x's and our y. So here we're at -7, -8. Okay. Now we do one more rotation to get over here. Okay. Do one more rotation to get over there. Now we just do it from the -7, -8 again. Okay. So where we flip it, change the sign. So now, we're at -8, -7. But again, we change the sign of the x. So we end up at 8, -7. One thing that'll help us, guys, as we rotate is if we're confused about these positives and negatives, look at what quadrant we're starting from. Okay, and if we rotate 90 degrees, okay, we're going counterclockwise. You know what I mean? So if I start with 7.8, I know, if I start in quadrant 1 and I rotate 90 degrees, okay, when I get to quadrant 2, that x has got to be negative because I'm in this quadrant over here. Okay, the x got to be negative, the y stays positive. Okay, when I rotate from here to here 90 degrees or whatever, right, I know that, okay, I'm in quadrant 2, so the x is negative, the y is positive. When I rotate from quadrant 2 to 3, okay, well, now I'm going to negative, negative. Okay, so hopefully we kind of see a pattern here, how we rotate, 90 degrees, 180 degrees, 270 degrees from our original point. Okay, and then of course we rotate it back 360, then we would end back up right there. Okay, so that's that. Last one, if we were to dilate, okay, that makes bigger or smaller. Now we're doing it about the origin. Now we're going to do sometimes without the, not about the origin, so that'll change a little bit. what would we do the coordinates of all the vertices? Well, we would just times the coordinates by 3. Okay, or we'll times it by whatever the scale factor of dilation is. Okay, so dilation is when we'll make a shape bigger or smaller, depending on the scale factor. The scale factor is bigger than 1, it gets bigger. If it's less than 1, it gets smaller. And so we just multiply all the x's and the y's by our scale factor right there. Okay, so we have these points right here. We're going to use these points to do these practice problems on E. And we'll talk about these when we come back the next day in class. And you take care, and y'all have a good day. Bye-bye.